Oh, no. Good. All right. So it is recording. And we're going to need every minute. And I'll just, yeah, I'm going to take it slower. So I'm going to slow down. That's the goal. So we're not going to get to every single thing in Desmos. And in fact, I already know it. I was going to use one from physics, one from chemistry, one in biology. And I just knew we had packed too much in. So this is the basics. And for every single thing, we might need another session. So if you are interested in that, that's going to be good to know. All right, so I'm going to show some slides to get us started. Excellent. And just, yep. So, okay, so introduction. This is the Desmos basics. And then a few advanced highlights. The idea here is you do actually get comfortable with all the pre-made Desmos. It's not teaching you to make a Desmos, although the very simple template will do everything from scratch. So that's a good way. Once you make it yourself, lots of times you feel better. Okay, idea capture tool. This is a very needed tool with this many people. So right now we're at 53. So not gonna be able to answer individual questions. And Desmos is finicky. So you're going to hear me say this a couple times, but it's very case sensitive. If you write capital M somewhere and later reference it as lowercase m, broken, no, Desmos will not work. It is completely unforgiving. So you can just see that. It's just very frustrating. All right, but the idea capture tool, I already have it open, so I'm going to try to go to it. Or nope, maybe I'll open it again. Parking lot questions. I'm going to routinely come back here and check. I will say I'm going to try to answer every question in there, but I'll just say this is kind of a preview. Right here, there's a stop and check for questions on what we've done. If you have a question on something we're not doing in the webinar, I will try to answer that, but it's going to be at the end of the webinar, not in the middle. So please don't take it as a disrespectful, but I am going to focus answering the questions on the activities that we are presently doing in the Desmos to try to keep everyone as much as possible moving forward. All right, I got these slides, so I'm going to quick show them. Of course, we got some upcoming webinars, but okay. All right, so Bradford Hill, science and engineering teacher at Mountainside High School. This is supported by the STEM Center and Oregon Department of Education STEM Innovation Grant that is paying for your attendance. We just know teachers should be paid for this, and that is amazing. That doesn't always happen, so that is great. Okay, goals for the webinar: introduce the basic architecture so that you know like why things break, or when students just accidentally delete something and then put back in what they think goes there and it still doesn't work. We want to learn the basic architecture so we can get to the bottom of those issues quickly, and then try out and build with some of this basic functionality. It's also worth noting that Desmos was built for math teachers. So they use, it is a mathematical program at its heart, but of course that's has a lot of crossover with science. So no surprise there. All right, so when you have questions for me, I'm really going to ask you to put them in the idea capture tool. I am not going to be able to keep up with the chat, unfortunately, but the chat is still a great tool. You can throw that out there, and many people, you might get that question answered. In fact, you might get it answered much quicker by throwing it in the chat. So know that. And again, I said I'll regularly check that idea capture tool, really prioritizing questions on the current task. Sorry about that. I know some people are going to make one little mistake, capital X versus lowercase x, and it'll completely break. All right. So the agenda is we are going to just do a from the, points, polygon, sliders. Then we are going to construct from scratch the standard template. We're even going to make error bars, uncertainty boxes one time. You only need to do it one time in your whole life. And that's just so you know, like when they break, why they're breaking. And it also teaches you a little bit of how to insert boxes and lines around things, which is good practice for us. Then we're going to go and use a standard simple template and run through it once, just as extra practice, exposure, practice, mastery, and then quickly take it to a little bit of advanced features that you might really use with students. So this is really meant to get you up to speed on how we're using Desmos in the patterns approach, how to fix it when it breaks, which of course we're going to do some practice of that, troubleshooting common issues. And then what is some low-hanging fruit that's right there that we didn't put in because it was just one step too far. But again, built-in easy differentiation. If you know this, you can throw it in on the fly if it's the right fit for your students. And then we'll take it a little bit farther. Another low-hanging fruit is the human brain plus the computer. So we'll talk about letting the computer find the best fit. And we call that, good science versus good science education. Really, patterns approach, it's more interactive if they find the best fit. But of course, a computer is going to be more accurate and precise. So we'll talk about using the computer to do that and how you can utilize that to deepen their thinking about curious data. A reach goal, which is almost certainly not to happen, but this is the first time we're running this webinar. So I didn't know if we somehow would finish early. I really worried that we're not going to finish early at all. But if we do, I'll take a peek and show you how I'm managing 55 people at the same time using Teacher Desmos. And that's a tool that you might want to use with your own students. It is more complicated, so we've always used direct graphing Desmos, but there's a question in the exit ticket. Please do fill out the exit ticket. We'll try to end with time. We need data-informed decision-making. So if you could fill out the exit ticket, again, it's the first time, so there might be some bumps. Really do appreciate. I really hope this goes well for you, so I'd love to hear if it did go well. And then whatever it's not going well and we can improve, that is, actionable feedback is really appreciated. Thank you. All right, next. Excellent. And then I believe that's probably Kristen here with the PMSP and see the chat going on. So
yep. Thanks everyone for your help with attendance. I greatly appreciate it.
Excellent. Okay, let's dive in because we're going to want just about every minute. So if you could, let me say these. If you could just click on this Desmos, that's going to take you to Student Desmos. If you can click on that, I'll just click it one time. And then if you could sign in, either with Desmos or Google, or you can continue without signing in. But do put your name if you're willing when you do sign in. All right, now while you're getting there, I am going to say a couple things. So what are a couple things to know about Desmos and common pitfalls? I want to lead with Desmos was made for math teachers. So there is just some of that lingo and, we have variables and then there's sets, and you remember there's just sets are different. That's a set of numbers, and sometimes we use a single letter like S to represent a set, and we know that from science as data sets. But Desmos uses sets in the mathematics way, which has a lot of crossover with how science uses them. But then the other thing to notice, Desmos is very case sensitive. Completely unforgiving. I think I've already said it 2 times, so I'll leave that one. And it's lowercase. Desmos likes lowercase, which is ironic that spreadsheets likes uppercase. Why did they not just go with uppercase to be like spreadsheets? Who knows these things? But they picked lowercase. So if you try to use a function in Desmos and you use like the spreadsheet capital letters of it, it just won't work. And, spreadsheets have gotten better where like, if you're trying to use average in a spreadsheet, most spreadsheets are now not case sensitive. You can use uppercase, AVG, lowercase, it doesn't matter. Desmos, it matters. It will not work if you don't spell it in the way that it likes exactly and in lowercase. Then the other one that really gets a lot of students, I was trying to be funny about this, but the equal sign is a command. So if you set if you use the equal sign, Desmos will make the things on the two sides equal. And that frustrates students because sometimes they assign what they think is a variable somewhere else in their code or on their side. They assign it a value and it will no longer vary. So, you got to be careful when you're adding things that, and the joke is it breaks mathematics. They think somewhere they've assigned it as a variable and somewhere they've assigned it, let's just say x equals 3. And then they say they want to plot y equals mx. Well, that is not going to plot a line anymore. That is going to give you a number depending on what m is. Let's just say it was 2. That is going to make y equal 6. And that is no longer a variable y. Y now equals 6, x equals 3 in that example. Okay, let's get to it. I was just kind of buying time. Let me check. This is a little bit concerning. Okay, good. Oh my gosh, I was seeing no one in here. All right, excellent. I skipped over this slide. So I want to say this. Here is what I suggest you do with your screen if you're able to. Definitely hopefully you have a big screen. If you could have the Zoom screen, just use half your screen and have the Zoom window, my shared screen. And then half the screen is your screen. It's just going to be really hard to listen and follow. And this is meant to be active and really want you doing all the things. Yeah, if you have 2 screens, that's even awesome. But I'm thinking if you have just a single screen on like a laptop, or hopefully not on like an iPad or a phone, this would be almost impossible to do. But Zoom screen and this screen. Yes, the agenda. Excellent. You really need the agenda. Whoops. I sent it to just one person. That's good. Oh, it switched. I think someone sent me a direct message. That's why my chat got changed. I did not see that, just so you know. So sorry, I won't be replying to that. I am not keeping up with the chat. That's the agenda, and I'll try to do a little better than that and write the agenda. So let me just verify that's the agenda. Okay, perfect. You really want the agenda. Okay. So oh my gosh, what am I showing? Okay, well, this is nice that I pulled this up. Oh my gosh, have I been showing this the whole time? Definitely, I don't know how long I have too many screens open myself, so I am gonna have to now close screen. So I think I was looking at the wrong screen when I was talking. Okay, all right. Okay, we are good. I'm gonna move this screen. All right, so I'm going to try to go. We are about to start. So that was a lot of talking to get us started. All right, so I see 32 people. I think we're having a couple more. I don't know if people are having trouble. Some people are just maybe getting on. So I'll quick from the top agenda. We're opening the link to Desmos. About to get started, but if you can log in and join us there. All right, so we are just in a blank one. And if you're still getting logged in, we're going to start, but this first stuff is real simple. So, okay, I'm really working my way right down the agenda. So if you even have the ability, you could look at the agenda, but slide 1, playing around with the very basics. So let's just quick make a point. So I'm going to go over to this line 1, and you got to put points in parentheses, right? From math class XY, but I'm going to put 2, 2 in parentheses. So that just makes a little dot at 2, 2. Most of the time in science, we really use this as a way to get text onto the screen. So I clicked on the label and I write, this is how we get text on the graph. There it is. And so often in science, not always, but so often we're in quadrant 1. So I'm going to click on the graph and drag the origin to the bottom left of my screen. Okay. All right. So just to go over, and this is just buying time for anyone that is still trying to log in. So I'm going to click and hover on the red dot on line 1. And I just want to show you the options. We can turn that text blue, green, orange, purple, black. Yeah, just to be thorough, you could make it a circle or a dot or an X. We don't really mess with any of that. In fact, lots of times I like the actual point to go away. So I unconnect the point, and then you can change the font, right? That's pretty small. So that A, if you hover, it'll tell you it's font. Or if you, that 1, if I change it to a 5, I get much bigger text. But it went off screen and I want to move it. So I'm going to click and hover again over that spot. And I'm going to click on the drag bar. Now it's draggable, and that up, down, left, right means I can drag it any direction. So now I can move this text to be in the middle of my screen. And I'm going to click and hover again on this, click and hold, and you can angle it. We don't use that too often. Mine's set in radians, which is non-intuitive if you don't work with radians a lot. Yeah, we could fix that with the wrench to angle, but that is not what I'm just going to put in a very small number. So we can angle the text. Yeah, just good stuff. And the opacity we'll play with a little bit later, but that's a number from 0 to 1, transparency if it was a Google slide. So we're just doing that 0.2. So you can see that fades it out a little bit. Okay. So I'm hoping, yep, we got just about everyone's here. Okay, good. Yep. Let's see a function and let's make a polygon. I just wanted to throw something in right away that might be new to people. So polygon, I wrote out the word polygon in all lowercase parentheses. This is a little bit painful. So let's make a polygon and let's make a square. And I did parentheses, and then you got to put in the data point. So parentheses again, I'm just going to quick 0, 0. And then you have to put a comma between the data points. Otherwise it gets thrown off. And then I'll put in my second point. I don't know. I'm just going to put in 0, 4. And then I'm going to go up. I'm trying to make a square. So I'll do 4, 4 in parentheses. Make sure you got all of those commas. There's a lot of commas in this. And then just the opposite, 4, 0 in parentheses, in parentheses. I have made a mistake somewhere. So I'm going to actually click on my triangle. Cannot multiply a point by a point. That's not that helpful. What I really forgot was a comma. So it thinks I'm trying to multiply, but really I forgot the comma between my two. And once I get it, boom, I get my polygon. Oh, yes. Good. I see the chat. See it got answered. Excellent. And it is linked in the agenda, but maybe if people are just joining us, I'll get that in there. But yep, looks like people are getting there. Okay, so I got my polygon, and let's just check those options pretty quick. So if I click and hover on that blue circle on line 2, I can change the color. I can change the opacity. They call it fill. That's funny. Sometimes it's fill, sometimes it's opacity. I guess maybe if it's a solid shape, it's fill. And then opacity would be like for the lines. I can make those lines thick. I'm just going to put in 5 or 25 to really show what that's doing. Okay. And then here, yep, opacity. See, they're very precise. Yep. Opacity would be for the line. Fill is for the filled in area. And I'm just going to make those very different so I can see the difference. Yep. The lines are really thick at 0.8. Fill is at 0.2. Good stuff. Yep. We'll see what you can do with polygons pretty quick. But right now it's just learning how to use a built-in function, put into points. This is not in the base curriculum. So this is just getting you familiar with Desmos. But we'll show some cool things that you can do with this in a second. All right. Now, let's add one more point. Colors and stuff. You have to, so if you're looking at my screen right now, on the second line, there's the green circle. If I click and hold for like 1 second, maybe 2 seconds, then you can pick the colors. You can make that a dotted line or a dashed line, all that good stuff. My line's a little too big to make those things look nice. There you go. That is good. Okay, let's learn sliders, which we use a lot. We use them in the mathematical model, but I just wanted to show it. So I want to add a fifth point to my polygon. So I'm going to do A comma B. And then, Desmos is smart and realizes, hey, A and B, that sounds like you want a variable. So variables, the easiest way to do them is to make them sliders. So I'm just going to go ahead and it says add slider. Yep, I'm going to add A and B. And you can just see where that fifth point is. So we're just playing with it. And I'm going to zoom out a little bit. And again, this is nothing, this is not a direct use. We are just in a playground right now. I wanted to get everyone situated before I started with stuff from the core curriculum. So, all right, but I do want to just show you the play. This, again, this is just almost in a playground. It doesn't make sense why you'd use it, but here you can just let A run between -10 and 10. Okay, well, what's to get used? I'm going to pause that because sometimes that can be students play. Some students will just turn on play and lose 10 minutes. Okay, now we don't always want to go from -10 to +10. So I'm going to have A go between, right here, I'm setting this, greater than or equal, A is greater than or equal to 0 and less than 5. Let's do 2 to make it really small. And step size. So often with our data collections, we want a step size of 100th. So step size of 0.01. Now if you have that small of a step size, you cannot, I call it wiggle. I don't know, that's a Bradford thing, so I don't know. You can only wiggle it from 0 to 2. If you want a step size of 100th, you can't have it wiggle between a very large number. If we set this from 0 to 200, even if we set the step size to 0.01, it will ignore you. It just can't have that precision with the slider bar. So know that if you want small step sizes, you have to narrow the range. Okay, so we can just see what's going on. I'm going to get rid of my dotted lines because they're messing with me. And then, B wiggles. And of course, you could wiggle them both at the same time. This has no functionality as it is right now, other than we're learning that how sliders work. Again, I'm going to turn off my B slider. And then if you see, there's the play pause button, and below the play pause, there is animation properties. If we click on that, you got to click and hold, or mine's, okay, there it is. Nope, that's interesting. Okay, so you just got to click, and then you can run back and forth like we're seeing it, where it just bounces between the two. You can always run it in one direction. And if you're in physics, you've seen this in some of the pre-made teacher Desmos activities, like where the image of the car keeps driving across the screen in one direction. Sometimes you want it to bounce, sometimes you just want it to run in one direction. We also use this in the climate change unit. All right, sometimes you only want to have it run through once. So that's that third one. Nothing very exciting about that. And you can also play indefinitely. Again, that's there. So I'm saying it. That I can't think of any use that we would have for that one. Okay, so now we're gonna do tables. And tables, of course we use tables, those data tables, that's what we do all the time. One last little base feature of tables that I want you to learn is tables are a great way to generate lots of movable points. So I just created a table. I went up to the plus sign and clicked on table. And I'm just going to quickly make some, like 1, 2, 3, 4. And then with Y, just to be quick, 1, 2, 3, 4. Okay, so I just made 4 points in blue. I'm going to get rid of my polygon so we can just see that. So I got my 4 blue points. And again, I'm going to make a polygon just to not introduce a new thing. Polygon, parentheses. I'm going to be very careful now. You saw how painful it was to program in point by point. And then you're locked in, and that just doesn't work very well. So I'm now going to do polygon parentheses, x1, you lowercase x1, comma, y1. Why this is nice, I'm going to teach a couple things. Why this is nice, so we got a polygon, but they're in a straight line. Let's see some functionality here. Okay, now you don't always want to teach students this because then it makes it very easy to fake your data. But, they're going to learn it eventually. So if I now go back up to my data table next to the Y1 on that blue circle for me, and I click and hover, I'm going to have first turn my data points purple, just for fun. And I am going to make them draggable. And now, because it's a polygon, I can drag my polygon. Oh, I accidentally dragged my text. And you can see this starts to show some functionality. If you are working with students on a graph and you're trying to draw their attention to a certain part of the graph, if you have this movable polygon, and you can make the opacity. So I'm going to click on it and make it fill down to like 1. It's just a nice way to highlight something on the graph, and it's very movable on the fly. And you can see my data table points are that text and the polygon together. Anyways, that's just a little nice touch. There's just a couple times that you're like, hey, where are you looking on the graph? Well, if you have a mouse, but sometimes you want to take a screenshot, all this good stuff. If you're really on top, yeah. If you're from physics, which I'm not sure, I just gave up on trying to give examples from physics, chemistry, and biology, and on the fly, I'm deciding to throw it in. But in unit 4, there's sometimes you just want to shade a graph when you're talking about it. So anyways, this polygon is a nice way to do it. Okay, nice. All right. A couple other options though. Let's go over here. I'm going to click on the Y again and bring it up. Again, just to see, you can obviously change the color of data points. Lines aren't going to make sense right now because we already have the polygon connecting them. So I'm going to turn off my polygon. So I turn on, and we could have, you'd say like, why make a polygon? Because a polygon you can fill. That's why I did the polygon. But I went back, I turned off my polygon, and I went up to the data table Y. Sometimes you have data table and you want to just connect the dots. Now, usually we do not want to connect the dots. We don't usually want to connect the dots. But there are just some times where you might want to connect the dots, and that is very easy to do though. Again, so you just click on there, you can change the color, obviously, you can change what type of line it is, solid, dashed, all that good stuff, the thickness. Okay, that is our basics. We're now going to get much more and try to use this in a way that we would use in science class. Okay, so we are going, and a couple of people, I'm going to move. All right, I'm going to check the parking lot. That's what I said I'd do. So let me do that. Okay, good. And just checking the chat. And the last thing I saw was got it. Thanks. Cool. Good. I think that is working. Yep. Okay. So let's move to screen 2. I could move you to screen 2, but I just decided not to. 2 of you are already on screen 2. So I might suggest you move back to, I want you to start fresh is what I'm trying to do. So, so if you did all of that on screen 2, you could either try to X everything out quickly, or you could go to screen 1. Some people someone's jumping all the way through all the slides. No problem. But we do want to meet on slide 2. So we're looking at a fresh sheet here. What's the best way to learn how to troubleshoot? Let's just build the basic template from scratch right here, right now. Okay, so the first thing we're going to do, and I don't know, I spent so many hours, I'm making this webinar, and going back and forth and trying to use fancy data tables that someone might be familiar with. But then I just thought we would get lost in like the questions about the labs. So I just decided fingers because I figured everyone was going to have fingers here. So we have the research question. How does, if you stack your fingers, which your hand does that nicely for you already, how does the number of fingers stacked affect the height of the finger stack? All right, the first thing we got to do is make a data table. So we're going to go to the plus sign, plus table. And look, it generates X1 and Y1. I will say that is the difference. I'm going to write this. You don't have to. X is a variable. So when I plot X, it makes that red line. Y is also a variable. It doesn't like that. We could even set that equal to X. That's good. X1 is a set. If you remember that from mathematics class, remember there's like a set, and I don't know, lots of times they use S for set because I guess set maybe starts with S. That makes sense. But you would say set 1 equals parentheses, whatever, 3, 4, 5, 6, a set of real numbers, that kind of stuff. All right, so that is a set, and that has to have the little number below it, X sub 1. Okay. All right, that doesn't, so often in class, we don't want students to use X and Y, they get confused. So this is our independent variable, F, and I'm gonna use capital F, and I'm just gonna type 1, and it knows what we're doing, so it automatically subscripts it. There is a hotkey for subscript. It's shift underscore. We might use that, we are gonna use that, I know, later. But the nice thing when it's a number and you're doing this common thing of making a set, it just auto does it. So our dependent variable on the number of fingers is height. So I'll do H. Oh, you know what? I just checked. It now works. If they mess this up, they can still plot points. So other things get broken, but let's just train up. Whenever you're talking about a set, a data set, you need the little subscript 1. It will now plot it used to not even plot points if you didn't have that subscript 1. It'll plot it, but error bars won't work and other stuff. So let's just always have F sub 1, H sub 1. Good stuff. Okay, data table. So I was going to let you vary a little bit and just estimate it. It's more important to keep moving. So kind of look at your fingers. Fingers are roughly 1 centimeter, but just look at your fingers. So I'm going to put one. Pinky is probably the smallest finger. I just wanted a little variability here. So I'm going to do 0, 1, 2, 3, 4, 5, 6. I don't know if we can do that quick, all the way to 6. So you can, I was not including thumbs. So, 6 would be 5 and 6 would be using your other hand, and just take a quick data set. 0 fingers should obviously be 0, 1. We're going to have a little bit of variability between us, and I'll quick show something neat about that. 2 fingers. Oh, I don't know if I'm definitely over 1. So, but I don't know. Sorry. 1 finger, 1.1. 2 fingers, 2.3. Don't overthink it. I'm starting to overthink it, so I'm just going to keep going. Okay, something like that. All right, again, we're in quadrant 1. So I'm going to click and drag my graph. So I'm hanging out mostly in quadrant 1. Ooh, I didn't have this on my list, but it seems like we should do this. All right. Yeah, is there a way to label the axes? Perfect. I thought people would want that. So let's go up to the wrench. On the graph, there's the wrench in the upper right corner. And you can see the x-axis. Yeah, it says add a label. So this we're going to say is number of fingers. And I was even thinking about this. Do you put score, or like when it doesn't have a unit, just, I don't know. I might rewrite fingers. I couldn't decide what to do with that one. All right. And then y-axis, height of finger stack. That cracked me up a little bit. In centimeters, comma, parentheses, centimeters. All right, good stuff. If we're covering the real basics, sometimes lots of times we might, the number of fingers is probably like, we know it's only going to go to like 0 to 10. So you might be tempted to say the x-axis should go 0 to 10. I'm showing this, but it doesn't work because you see how that literally makes the y-axis go right up against, I don't know what to call this, the data entry thing on the left. So you got to give it a little buffer. So it's like -1 to -10. And then we're going to see the same thing with y. Y should go like -1. I do like it whenever we can get it to be 1 to 1. So I did 10. Okay. So that's, now we got a pretty good looking graph. Height. Yep. Number of fingers. We got several data points. All right. So now we know that we're going to need a slider and a constant in our equation. Yep. So I'm going to say C. That is interesting. Good. So, yep, interesting. So I want to vary C from 0 to just 5. So I'm going to enter that, and that's going to turn it into a slider. If you just say C equals 3 and don't give it a variable range, it won't give you the slider. So you can just see a slider. Lots of times you write the mathematical function, then ask you if you want to turn something into a slider. Okay, I wanted to make mine first because I wanted it on top. All right, so now we need our mathematical models. So again, the simplest model, y equals a constant, almost never comes up. So I want to skip that one. Well, I'll say this is the Desmos one. So if we wrote height equals a, it doesn't work. You see, it's giving us, it really is treating those both as variables. The only way to make a horizontal line, unfortunately, this is a quirk of Desmos, is to use y. Y equals our constant, C. Sorry, I switched to A by accident there. We used to call it A, but okay. So that's the constant line. It's unfortunate because we tell students not to use y and x, use the variables that have context meaning. So I'll leave it there just for completeness. The rest of the time, though, I'm going to use height. So then the next simplest model is proportional, y equals c. And again, x would be the normal thing, but for us, our input variable is not x, but f. So I'm going to use f. Yeah, the c value, sorry, the better way to do c value is the type line 4, h equals cf. I'm going to get rid of my c. And as soon as you do that, if you write h equals cf, it'll say, hey, c, do you want that to be a slider? And yes, I do. So you just click OK. I wanted it on top, so I made it. I will, just because I do try to answer the questions as they're asked. So I'll just show it how I did it the first time. I get a new line and I say c equals, I don't know, 3. I just had to give it a number, so it gave me this option, this new menu. And see here it says vary c between where. I'm going to do 0 and 3. And I can choose my step size if you want to go by hundredths or tenths. I don't know. I'm going to pick tenths. And now I have my variable. Okay. So we have our two simplest models. And of course, that's the simplest model. That's good enough. So we're already there. But just for completeness, what's one time right in h equals c, capital F squared. The way to do squared is shift 6. That's that caret. It doesn't show the caret, which is really nice. It just goes into superscript mode. So there's our quadratic parent function. It's all good stuff. And just for completeness, I don't know. There, of course, as chemistry and biology add ones, C divided by H. The nice thing is it makes it, whoops, why did I should have done F there. The nice thing is it auto makes the nice fraction. Okay. All right. So we have several models. It's pretty obvious what it is, but we really want, how close is close enough? This is such good data. It's so close. We don't probably even need uncertainty boxes, but that is not usually the case. And we really want students to answer the question, how close is close enough? Well, the simplest best fit line that goes through all of your uncertainty boxes. Okay. So what's one time? And you're going to see why you only want to make these one time, and you want students to start with a Desmos that has these pre-made. All right, I'm going to unclick the little highlighted boxes for all of those lines. So we're keeping them, we're just making it not show up on the screen. And if you get totally lost, I'll say starting at slide 10 is the answer key. So slide 10 was the answer key for slide 1. Slide 11, I'm going to just flash over there. I want you to just follow along. But if you get super lost on slide 2, slide 12 is the answer key. Okay, but stay with me if you can. All right, so line 6 is my last line. I now want to, it's just Desmos, so we got to make a new line. So I went down to 6 and I hit enter, or you could go up to plus sign and put an expression. All right, I'm going to think ahead a little bit. Actually, I want to show that. I want to put plus note. So if you want to enter text, you got to do plus in the upper left corner and pick note, and it's in quotes. And that's the same thing with spreadsheets, by the way. When text, you got to put it in quotes. So, okay, otherwise it tries to turn it in a function. You're going to get an error message. All right, I just want to say, horizontal uncertainty. Okay, that's the uncertain, and then I'm going to hit return, which is a new line. And you can get, I want to keep this as simple as possible. So the horizontal uncertain, oh no. Oh, yikes. We already used H for height. Huh. I used lowercase h. The answer key has lowercase h. So that's a little bit confusing. Sorry about that. H, our horizontal uncertainty, we're making a new variable, h equals, we could turn this into a slider, but I just want to set it to a value to keep things simple. Now it's funny. What's the uncertainty in your fingers? It's probably 0, right? Like you can count your fingers, but let's just say like there's just situations that like people have injured their finger, or I don't know what the physical context is. I didn't think about this until just now. All right, so 0.5. If we just hit enter, h is going to equal 0.5. Our horizontal will be half of a finger. So look at that, it auto turned it into a slider. Okay, good. And then we need the vertical uncertainty. Oh, look at that, I just started text. I'm getting all these error messages and sliders because I was in a program line, not a note. So I'm going to turn this to a note. So I go up to plus sign, hit note, and I have to X that one out. Okay, vertical uncertainty. This one is nicer because we can just use V, and I'm using lowercase. And the vertical uncertainty in centimeters. Do you want to make it the same or different? No, probably different. And I'm going to say the horizontal uncertainty, we were just using our fingers. That was kind of hard. So I don't know, 0.8. Whoa, gosh, I hit 0.8 a bunch of times, but it seems. Okay, so then new line. Okay, now think about it. I'm going to pick this one right here because it's right in front. I'm picking 2 and 2.3. What's the uncertainty? What do? You take the data point, and in the worst case, you add the horizontal uncertainty, and it could be anything right there. So, whoa, that was not a easy to follow sentence. So, think about, we want at each of these points, we want to draw a little box, and the box ought to go higher than the data point by the vertical uncertainty, and it ought to go lower than the data point by minus that uncertainty. And then of course it ought to go to the right of the data point by the plus the horizontal uncertainty, and I go to the left. So this is complicated. Really stay with me. Watch me, and then I'm going to pause for like 30 seconds. I'll try to check the chat, but watch. It's kind of a I do, you do situation because it's just complicated. Okay, I'm going to start. Which bar should we start with? I'm going to start with the right bar. So I'm going to use capital R. And I did want to show this. This is the right bar. So I wanted to show you how you can quick get subscripts. Sometimes you want to label things. So shift underscore, that's the key to the right of 0. And I'm going to write bar. So I'm doing the right error bar. And then I'm in my subscript. So I hit the right arrow, pops me up into normal text. And then I'm going to do equal sign. All right. Now I got to wrap my head around this. Whoa. Okay. We want to plot X. Oh, I want to X. Oh, sorry. X. Yeah. We want to do this for each data point. So, whoa, I got to think about this. I want to do, my data point is F1. That's my X. So for each data point, so I'm going to write F1 because that's a set of numbers. See, it tells me right here, there's 7 elements, my 7 data points, 1, 2, 3, 4, 5, 6, 7. Okay, for each of those, I'm making my right error bar. So what do I want to add? Each of those points, I want to add, I'm doing the right bar. So is that horizontal or vertical? Well, the line will be vertical, but I want the line shifted over plus H. Okay, good. So I mean, nothing's coming up, but I think we're all good. All right, now we only want to plot that right error bar for the Y values from the Y value at that point, or H1 minus the uncertainty plus the uncertainty. Okay, that's a lot. So let's do that. I'm going to just, I kind of got to get my home base. So I'm going to write Y greater than, that's then H1, the Y value of our variable, H1 minus, this is the low end, minus the vertical uncertainty. So that's V. And right now it's screaming up to infinity. So we got to bound this on both sides. I only want to plot Y between these two. So I'm having it start at whatever the data point is minus the horizontal. And of course, I now want it to be less than, and I'm programming it weird. I didn't do it well. So I put it less than, and of course it's going to be H1 plus the uncertainty, the 0.8 meter. So I'll do plus V. And there it is. We have our right side, the right bar of our uncertainty box. And woo, our uncertainty is so big. Let's shrink it. I'm going to move the height to 0.1 and the vertical to 0.3. That looks a little better. Okay. Yep. And that was the toughest one. So I'm going to pause here. I'm going to check the chat, make sure you have everything matched. And now we're just going to do this. We can almost copy and paste this 3 more times and then think about what you want to change. But get this one dialed in. And I'm just going to say, I'm going to repeat what is being done here. And then I'll try to give you silence for about 60 seconds. So we made the right bar of the uncertainty box by going to each data point, F1, and adding the horizontal uncertainty. That pushed us to the right. And then we only plotted Y values between the data point plus the vertical uncertainty minus the uncertainty. How do you get subscript? Subscript is shift underscore, that little line next to the right of 0, between 0 and plus sign. It's actually not necessary, but I'm just trying to teach you lots of things. So the nice thing is, I'm going to give you silence for about 30 more seconds. And anyone who's on video, thank you so much. If you're willing to give me just a thumbs up so I get one data point on who is done. Thank you. Okay. All right. Well, then I'll do this next one. You can guess what we're going to do next. We're going to make the left data bar. So I just copied and pasted because that's a lot of repetition. And I'm going to change the the R to an L. And then think, what do we need to do? This is the left bar. So we want to go to each data point, and instead of adding H, we now want to subtract H. So that will pull the bar to the left. Whoops, I did it on the wrong one. All right, on the left one, we'll subtract the horizontal uncertainty. What is that? It looks like a TIE fighter to me. If you're into Star Wars, you'll get that reference. How do you get brackets? The curly brackets are very important. I didn't really say that. Curly brackets are different than parentheses. And yep. Curly brackets, though, are shift. You know, it's the 2 to the right of P on the keyboard. And you use, it's interesting, you use curly brackets differently than parentheses. Usually you use curly brackets when you are limiting the range of a variable. Yeah. I don't know like the precise definition. It's interesting, but yep, we will use curly brackets a few times in this. So I'm doing a time check. Ooh, okay, we got to kind of get moving. So, all right, let's go for the top bar. So again, there's a lot more changes, and you get the idea now. So I almost want to move on, but for thoroughness, let's go ahead and make the top bar. So I'm going to change that L to a T. And now, instead of starting with the X variable, our independent variable F1, we want to start with our Y variable. So I'm going to change that F1 to an H1. And then I'm going to go to the top bar. So that negative sign turns to a plus sign. And I don't want to add the horizontal uncertainty. I now want to add the vertical uncertainty. So I'm going to change that H to a V. Okay. And it's a little bit funny. Yes, I saw that comment about the inequalities. We'll fix that, I think. But now, again, so what are we doing? We're making a little bar across the top. And instead of the values between, let's change this Y to an X. And we just got to really change everything now, right? This H1 turns to an F1. Everything flips. And then instead of plus V, we got to switch that horizontal to a vertical. And then got to bound it on the other side again with the X variable, because that's what we're talking about, and minusing, not V, instead H. And then boom, we got our top bar. Yep. And just know that inequality message is because you temporarily have you're telling it to do something with Y inside and outside, and it's getting confused. But as soon as you change what's in the brackets to be relevant to the X variable, number of fingers in this case, it'll resolve that. The triangle might well, if you hover over the triangle, it'll tell you it. Usually what you've done is you've told it to do that's that whole equal sign. Somewhere you've told it, maybe you didn't change the L bar. If you, in two different places, assign a single letter of the alphabet to two different equations that can't be equal to each other, it results in an error. Too many variables. Yes. You really got to check everything. There's some minor mistake. So at this point, I just want to keep moving. I think it is the right move. If you want to just check the answer key, hop to slide 11. So that'll have the answer key. Here is the answer key on slide 11. But let's go back. Oops. I'm going to go back and just finish for the, let's do the bottom bar. Or I'm on the answer key. That's why I was like, wow, it's already done. Okay, bottom bar. I am going to copy and paste what we just did. And if you want to, anyone who messed up that last one, just exit out and just go for the bottom bar. You can tell if you make the bottom bar, you could do the top bar too. So I'm going to call that B bar, B for bottom. And again, we want to take the data points for height. And instead of adding the vertical uncertainty, all we have to do is switch that to a negative. And doop, we got our uncertainty boxes. And as you can see right now, right? People basically have this and you just miss one thing and it all breaks. So this is why we never have students do this. And, you know, other software programs never make students code the error bars, right? If you use Mathematica, you just say insert error bars and boom, the computer does all of it. So we normally hide this in a folder. Okay, I'm doing a time check. I think people for continuity, let's move on. That is not a mission critical thing, but the answer key is on 11. So let's go to slide. Oh, I said I would do the parking lot. So I think I'm keeping up with the chat. I hope I didn't miss someone if the chat got too far ahead of me. All right, slide 3. Slide 3, practice with a simple template. I already put the data in just to save time. This is what it looks like in physics, and we're going to try to make them common, physics, chemistry, and biology. So we'll get together and we call this level. This is a little bit helpful. It's already been filled out, the F1H1. So okay. I just want to make sure I didn't miss. Yeah. Okay. Let's find the best fit quick. That's not the point. Oh, I did this intentionally. So right now it's going by whole numbers, which is kind of annoying because we can tell it's between 1 and 2. All right. So I can read, it's really small, and I'm sure it's small on my Zoom screen even more. It's saying it slides between 0 and 100. Okay, well, when you slide between 0 and 100, your step size has to be whole numbers. So I'm going to click on the 100 and give it the option. I know I only need to go up to 2. So I'm going to vary it from 0 to 2 and now make my step size 0.01. And now my slider will give me a lot more sensitivity. And just to keep this moving, about 1.25 seems perfect. All right, and as we so often do, let's get rid of, I was convinced by teachers. I used to always just unclick keeping these in case they made a mistake, but so many kids get confused with the equations on the left that we're not using. So let's go ahead and just X them out. All right, so we got our nice equation. We can write in our mathematical model. I'll just do that really quick. Height equals 1.25 times the number of fingers. And we really like to write out variables when they write it. You know, so many students will forget what H is. And sometimes they'll put N for number of fingers, F for fingers. Let's have them write it out, number of fingers. I don't like that little dot there, so I'll just unclick the red dot. It looks a little nicer. It's still drag. Oh, it's not allowing me to drag it anymore. That's interesting. I'm probably just not grabbing it in the right spot. But anyways, so it's draggable. That's already something we saw before. Okay, let's go on. So that most students don't have a trouble with this. Oh, we learned from chemistry that, you know, it's just one more thing. So at the beginning of the year, we don't do this, but starting mid-year, we want them to add a title as well, right? Like any graph should have a title. But with freshmen, it's always, you know, one more thing to get lost. So we have them just do the mathematical model at the beginning of the year, but then let's write a title. So I need a new data point. And I'm just looking at my graph, 5, 5. I just need a point. So I can click on label and I'll title this, how fingers stack up. You know, there's a running thing of like, what should a title be? Should it just be like height versus fingers? Should it be more descriptive? Should it pull the audience in? All good questions, not anything we're going to talk about today, but just know that. And I didn't make it draggable. So I got to click and hover, select the drag feature on, and now I can move that up. That's good stuff. And it kind of moves on you. So I'll show that because I haven't said it. These little things, I can make it go above the line, below the line, to the right of the line, or if you make the line disappear, then it moves a little bit on you. So I'm going to leave the little blue dot to the right. Okay, that looks pretty good. I was going to have us practice the polygon to just put it behind to make it pop. just that little thing that a student finishes 10 minutes early and you want them to do something productive, you could teach them the polygon quick and do that while you're helping students that are confused about the lab. But that's just a simple little touch, nothing important though. All right, now I want to show a couple more advanced features. Okay, let's say we want to predict the future, but let's say the next 4 fingers are from a kindergartner. All right, first things first. So we know right now this red line goes infinity to infinity. We know that it really shouldn't. You only have 8 fingers because we're not including thumbs. So let's actually have our model show that. Okay, curly bracket. I only want to plot values. And I think you have to use X and Y always, which is a little bit annoying. Sorry about that. 0, I want my X to go from 0 to 8. Whoops, 0 to 8. So I use curly bracket 0 and then X greater than, ooh, it didn't like that. Why? Because I probably had, I'll look, too many variables. F. Super surprised about this. I got to slow down and think for a minute. It's not recognizing that X and F are the same thing. That is funny. So I'm gonna look at my key because I got myself confused right now. Yep. Gosh, I can't believe it. No, I only want to plot this for F. Obviously, that was the mistake. It was not linking F and X. Good. With Y, sometimes you have to use Y, not your variable. X, it does work. Good. That threw me. Sorry about that. Okay. So I only want to plot my best fit line from 0 to 8. Okay. So for fun, this is line segmenting. I know chemistry wanted to make sure I taught this. So I didn't want to jump to a whole new lab though. So let's stick with the fingers. Okay, if those next fingers, so after I did the brackets 0 greater than F or less than F, less than 8 curly brackets. Okay, so I'm only plotting it from 0 to 8. That's nice. All right, now I'm going to plot the same line again. 0 equals C, but our fingers, or the example here was 1.25, a kindergartner. Let's just be on the same page. And I try to pick a kindergartner with a little fingers. So instead of 1.25, a kindergartner would have like, instead of 1.25, they'd have like let's just do 0.25 to make it really easy to see, times F. Okay, so that would be the line for them. But they're going to stack their fingers on your fingers. So we need to quick add an intercept. And for lack of imagination, I'm going to do plus B and make B a slider. And then look at this. I'm just going to slide it until it connects to my existing graph. Boom, right there. What is that? B equals 8, of course. Okay, B equals 8. Now, of course, they only have 8 fingers. So I only want to plot this, okay, curly bracket. I don't want this line to start until 8. My blue line, I don't want to start till 8. So I'm going to write 8 greater than F. And our little kid only has 8 fingers. So that'll be 8 to 16. And so here we have lined segments. So, and just there's different chemistry. There's tipping points. There's something in the system changes. And so sometimes you have this, and there's multiple examples of this. So I'm not going to harp on that. But just a quick check. I'm going to scan. No new things on the chat. So hoping that is going well. But again, that's line segments. Good stuff. Okay. Okay, cool. Here's just a bonus. This is the basics plus an advanced feature. This is something cool. You do need to go to the agenda quick and download this image. So I'll put it in the chat. That just is the obvious thing to do. I'm going to put it in the chat. Chat disappeared on me. There it is. Oops. Okay, file. Okay, go there, click on that. I'll show that. And then you got to go to the, download. And then for me, you click down here and say like show in Finder. Okay, I got it. All right, so let's see. You can see I'm going to insert an image, and it's going to be that image. I'll give everyone a second to download it, about 20 seconds. And okay, if you have it downloaded, we're going to go up to the plus sign. I'm back in line 7 after typing the kindergartner's fingers 8 to 16. I hit return. I'm going to go to the plus sign, and you can insert image. So I'm going to insert image, and it automatically went to my downloads, which is nice. But you might have to, find your folder with downloads and click open. All right, so it inserts the confidence matrix right there. And again, this is not exactly how you do it with students. I'm just trying to get all of the good stuff. It's leaving it to the imagination exactly how you'd use it. Okay, so I'm now going to click on the image. If anyone, I'm going to try to be real slow right here, but if I'm a little, I don't know if, does anyone need more than 30 seconds to get the image? Okay, looking pretty good. So I'll just buy a little bit of time here. So we're just looking at this. You could change the images, the wrong one. You can do, center, the angle, opacity. That's all good stuff. Most of the time, it's easy to resize it on the screen. So in order to move the image around, you got to grab it from the middle. There's a little dot. It's a little hard to see because it's blue and the image is blue. I thought this would be kind of cute. I'm going to drag it, and I want to resize it. So I'm just going to, just like you would in like Google Docs or slides, I'm going to grab the bottom right corner and drag it, and it resizes. And I want to make this a little more up and down so it got misshapen a little bit. Okay, so I'm going to put that down here. And I want to shade. I want to line it up a little bit. I'm going to try to be predicted within the data range. I'm trying to make that be right under the literal data range. So I might shrink mine again. That's not the point though. So, okay. All right. So here we go. Oh, this works really well, I think. Okay. So I want to teach you inequalities in shading. This is an advanced move, but there are, there's a data set that we are, in our data range, we're going to be really confident. So I want to teach you that. So I'm going to go back over to I need the name for this. Could someone in the chat, what do you call this screen on the left, the command lines? In any case, I'm going to go to the plus line and write new expression. And there is several ways to do this, so I'm just going to show you one. I'm just going to start with x greater than 0, which of course does that whole right expression list. Thank you. Okay, so right now it's that whole thing. So I only want to shade. We could make it vertical, but I think I want to show you that we can shade just under the graph. If you want to do area under the curve, but I'm just going to show that to you. So we only want to plot this for values of y greater than 0. So I'm going to start with 0 greater than y. So now I'm doing all of quadrant 1, but I want it to be less than the line. Ooh, this is the one where I think we have to. I want to say less than capital H. but it will, this time I'm sure it won't work. So we have to quick tell it a function it understands. Y equal H equals 1.25x. It didn't work. Why? Because I probably defined that already. There's too many things in my head, and we kind of made up arbitrary. Let me just check this quick. What did too many arbitrary ones. H, yes. Okay. CX. So close. Okay. Yeah, that should work. I don't know. I was rewriting it. Oh, I know why, because I use capital H, right? It's case sensitive. Okay, perfect. There it is. Sorry about that. Okay, so let me back up and say what I did. I'm plotting values of x greater than 0, which is everything. And then I plotted it only for y values greater than 0, which turned it to quadrant 1. And then I said less than h. Sorry, lowercase h. And you think it should work with uppercase h, but it needs it to be an x. It doesn't, and that's the graph. We did all the mathematics, right? But it doesn't see it as a graph. It doesn't see this as a graph, although it does graph it. So sorry, I had to remake, and I think we have to do this. So I'm going to move forward though. It shows it. Sorry that line 9 and line 5 are basically the same, except for I didn't want to use, I could have used capital H, but it doesn't matter. It just needed the X in there instead of the capital F. You could just use CX without defining H. Okay, good. Yeah. Sorry. Yep. Right here, we could have put the CX. Yep. I always like to do it that way, but yes. Okay, good stuff. All right. And let's be clear though, I don't, right? So I'm trying to use the confidence matrix to give a story behind it. We only want to, our data went up to how many fingers? Oh, in this example, we only went up to 4. So I want to plot this for x bigger than 0, but less than or equal to 4. Boom. And I want to change it to blue, right? And I'm going to change it to blue, and I'm going to make the fill, I'm going to make it 1. No, I'm going to make it 0.9. You'll see why in just a second. Oh, 0.8. I should have stuck with what I had done originally. Okay, then I'm going to copy and paste that, because look, when the predicted range, it's dark blue. Near the predicted value is medium blue. So you might guess what I'm about to do. I'm going to copy line 8 and paste it in a new line right below it. And where are we near? Well, that's probably when you have your same 4 fingers. So I'm going to plot that same thing, but from the X range of 4 up to 8. Because if it's my own fingers, I feel good about it. I'm in the near the data range. Oh, and I'm going to turn off that graph so I get rid of my red line. And then once you get beyond 8 fingers and you start using a kindergartner's fingers, okay, we're getting kind of worried here that the mathematical model might not work so well. So that is the predicted value far from my data range. So I don't want to type it all out from scratch. So I'm going to take line 9, copy, hit return to get a new line, paste it, and then change it for 8 up to, well, a little kid can have most likely up to 16 fingers. And again, I'm going to change it to blue, and I'm going to make the fill just 0.1 to make it really light blue. There. I was hoping you'd find that cute, that we kind of justified looking at inequalities. So the Desmos goal here was look at inequalities so you can see how you can shade a graph. And why might you want to shade a graph? Area under the curve if you're doing that kind of thing, or you're just trying to match up the confidence matrix to your lines. Okay, we're at 520. That's good. All right, that is all I'm, oh, okay, let's troubleshoot. I'm going to just try to utilize as much as possible. Let's all move to slide 4. They can get you there. And we're going to whip through these. We'll get through all of them in the next 10 minutes. So, all right, someone, you said I couldn't copy and paste. Joke's on you. Student, copy and paste. The data points show up, but the error bars don't work. Okay, look, what happened? Yep, sorry. I will circle back to the inequalities, but I am going to do the troubleshooting. All right, and people are a little bit scattered. About 10 seconds. If you see the problem, if you put it in the chat, just so I get some affirmation. Yep. Yep. So, oh, their error bars are not showing up because when they pasted their data table in, it generated X2 and Y2. We want it to be T1 and D1. And so this is what you see when students copy and paste, their points work and they can even use the slider, but they need to, they got to remember this. So I have them type it first. Let's change X2 to T1 and that Y2 needs to be changed to D1. It's still problematic because we have 2 T1s and 2 D1s. So I'm going to delete the empty data set and pow, there they go. They show up. Okay, that's all we're doing on this slide. So that's it. Okay, so that's a very common error that when the people copy and paste, that kind of works sometimes, but you got to reassign the data set for the set that was used there. How do you copy and paste it? Literally, you just, yep, I didn't show that. And I'm going to rifle through that. I will try to get to that though. You have to have like a spreadsheet open. So we don't have that, but I will. All right, here is another one. If I'm on slide, I don't know if this will be helpful or annoying. I was going to jump everyone here, which shows like a nice tool. That annoys you. Sorry about that. I heard C was 0.3. So they're using their slider, but nothing works. Okay, so if we look, what happens? Some student heard it was 0.3, so they just typed in C equals 0.3 down here and here. So you can tell you can't make C equal to 2 different things. So they got to delete it. That's another common one. And once they delete it and C's only defined one spot, the error bars, or sorry, the slider works again. Okay, I'm going to move everyone. Look at this one. I'll give it. This one is a little more tricky. I don't get why Desmos doesn't work. We look at this one. And if we look, we've written these equations, D equals CT, and C is some number. But look, all of a sudden, instead of all of a sudden, look at this. There's this weird like fraction over here. And it's giving a value for D. Oh my gosh, look at line 7. They didn't let T be a variable. They assigned T equals 0.3. Well, these equations to work as a line or a quadratic need T to vary. And T can't vary if it's assigned to be equal to 0.3. So as soon as we get rid of that equal sign, making T be 0.3, boom, T can go back to being a variable and our lines show back up. All right, this is the hardest one and it should never happen. Or no, I had my uncertainty boxes, but then they disappeared. Classic case. If you hear that from someone, what happened? Well, you got to know a little bit of the structure, which I'll show you next. But look, they accidentally deleted T. And when they rewrote T back in, it was lowercase. And the program was set up for it to be uppercase. Oh, look at that. And then I lost all my data. No, as soon as you type it, it'll reappear. Okay, so capital T, and then error bars pop back up. So classic case, if they had uncertainty bars and then they disappeared, usually because they accidentally click in there and they think they're fixing it by writing lowercase t1, but they disappear. All right, and our last one, this should never happen, but somehow it still does happen. They're not, hey, this is capital T1 and capital D1. Everything looks okay. Yep, the sliders work. Not for editing. You'd think that makes it so people wouldn't go in there and change it, but sometimes that's like just the invitation. Look at that. X1 was assigned lowercase t1 and Y was assigned lowercase d1. Somewhere, if you don't use X and Y, you got to tell the computer what you are using. So we use lowercase t1 and lowercase d. So up here, we would have to type these to match lowercase, and then boom, error bars and uncertainty boxes are back. Okay, 4 minutes. All right, last one, super advanced feature, they're low-hanging fruit. I want to let people do this one. Sometimes you want to let the computer find the best fit. You know, there's good science and good science education. Good science is let the computer find the fit. Good science education oftentimes is let the student find the best fit. But let's talk about it. If you want this computer to find the best fit, I need a new line. I am going to do it at the top. So I'm on line 1, I hit enter. So I have a new line. You got to tell it for that set. So we want D, not generic D. We want specifically D1. And instead of using an equal sign, you have to use tilde. That's the key to the left of 1. Shift, the key to the left of 1 is tilde. And that looks quadratic. So I'm going to go ahead and just put that in. C is C is already defined. So I want a new variable. I'm going to call it A, and then T squared, but I want not any variable T. I want specifically the data points T1. So I got to put T1 and I need it squared. So that's shift 6 and put it 2. Whoa, 2. And now the computer found the best fit. And that's when A, my constant, is 0.31. I wanted to show, actually, if you did this by hand, I did want to show it one time. Students routinely get 0.3. So they're off by just a couple %. By hand, students do a really good job. But in any case, sometimes you want it dialed in and you want the computer to do it. So you use the tilde. And for fun, we got 2 minutes and I didn't see questions in the parking lot. So I'll just say, check this out. If you plot the residuals, I'm going to make the lines go away. That shows you, that green dot down below shows you how the data point is off from the actual best fit line. And do you see a trend there? The first 3 data points are above the line. The 4th is kind of at the line. It kind of perfectly overlaps. And the last point is below the line. And this is a ball on ramp. This is too quick, but I just want to show you. This shows you there's a bow in the ramp. They didn't support it. And you can imagine if a ramp is straight, this should be a perfect quadratic. But if it bows, it's going to have extra acceleration. It's going to be extra steep at the beginning, and then it's going to flatten out at the end of the ramp. And that is actually what we're seeing here in these residuals. So sometimes looking at the residuals lets you troubleshoot why data points are off. Now, if it's random error, that wouldn't help. And random error would show up as random points. The residuals would sometimes be up, down, up, down. But when there's a clear pattern of always above and then always below, that's probably a systematic error. Okay, so please do the exit ticket. Would you want, that was, the basics and a lot of the functionality. You can tell we filled up the 90 minutes. Please, what went well, what didn't go well? Would you want another workshop that would get at specifics from physics, specific from chemistry, biology? I know standard deviation is one that might be worth it. So if you could fill out the exit ticket, it really is like 4 or 5 questions, and especially the first 3 would be super helpful. That's something we always do, and I hope to keep it going. If you're willing to unmute, and we'll do a 3, 2, 1 countdown and bye. I'd love it. I'll hang out for a couple extra minutes to see if there's any, just burning questions. And so we'll get ready to do the 3, 2, 1 and good. Yeah. Thank you. Appreciate feedback though. If you could do the exit ticket, that'd be awesome. All right. So if you're ready, 3, 2, if you can unmute, 1. Bye.
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 Thank you.
Yeah, you're welcome.
Bye, thank you.
Thanks, Bradford.
Yeah, you're welcome. That was helpful.
Hey Bradford, I have a completely off-topic question for you.
Yeah. I'll see what I can do here. Yeah.
Do you play pinball at next level?
No.
Okay.
Yeah.
I'm a big pinball fan, and there's somebody with all the high scores named Bradford.
Oh yeah.
Okay. Cool.
Yeah.
Hey, thanks for this. This was awesome.
Okay, good.
Yeah. Have a good one.
Yeah, you too. Yeah, I see Eli and Carrie, questions or yeah. You're muted.
I know, I'm sorry. I was just wondering, my students are having a really hard problem with the, and then this is kind of off topic too, predicting whether a prediction is near or far from the data set. And like, I'm having a really hard time I can't give them a straight answer. So do you have a certain way that you teach that?
I do, and I'll say people don't like, or some people like it, some people don't. So it's like, some people will like a hard rule, which I don't like a hard rule. So, but nothing wrong. Like we leave it there to generate discussion. And
yeah,
if
and
that's
happens every time.
and if it's turning counterproductive, turn it into a rule. Some people have it is double is the breakaway. So once it's 100% passed, that's fine, but it's really contextual. And I like that discussion. And so like, and so I want to give you a couple options before you. So one, just decide each lab let the class talk about it, instead of just setting it as 100. If 100 works for you and that keeps the eyes on the prize, then go for that. But if the next step would be, hey, as a class, let's talk about it. Like a paragraph isn't really going to change from 20 to 30. But when we start to get close to a single line of a paragraph, that's when things really get weird. So, I'm talking like a 1-minute conversation with the class. So a bowling ball on a floor. Well, if we're in the classroom, it's going to be the size of the classroom because it's going to hit the wall. But if we're in the hallway, ooh, that's one of the best discussions.
Yeah. Okay. Yeah, that makes sense.
So,
okay. Thank you so much.
Yeah, you're welcome. Eli, do you have a question or yeah, make sure I have your name right too. Yeah, any questions for anyone? Okay, great. Please do fill out the exit ticket. And we have a couple more slotted. We are going to start to try to integrate with some math teachers. So we generate Desmos as a tool to connect math and science classes. So we got to decide, should we do another one for science teachers or should we open it up to math and science? All right, with that, I'll see everyone next time, hopefully. Good night.